You know, probably when we all get on airplanes, we don't think too much about the engines.
The engines don't happen quite overnight. There are just hundreds of millions of dollars to develop a new engine.
We're going to have 60 different builds of the LEAP engine before we enter service. That'll accumulate about 40,000 cycles. That's 15 years of flying. We spend a lot of time making sure that we're right and that we're safe and secure before these engines will ever enter service.
We recognized several years ago that the efficiency we have in our current engines just is not adequate for the future. The LEAP is a brand new beginning for this industry. LEAP will bring 15% reduction in fuel consumption. It'll bring 75% reduction in the area affected by noise around airports, and more than 50% reduction in emissions. 15% reduction in fuel represents about a 10% reduction in all the cost of the airline operation. So that could be the difference between profit and loss for an airline. LEAP has a suite of new technologies: 3D woven carbon fiber in the fan blade, ceramics in the high-pressure turbine. Our fuel nozzles are 3D printed directly out of metal to the finished part, which has never been done before. The first use of additive material technology ever in aviation.
So this is one of the fuel nozzles that we have additively grown. It's a very complex design. This part is in a very temperature-elevated environment. It is the heart and soul of the engine relative to the propulsion. So this part can't fail. The additive metals technology works by taking a very fine metal powder, and it utilizes a high-powered laser beam that's focused very precisely. It's actually melting that powder into a solid, a third the thickness of a human hair. And then we drop the platform 1 layer thickness, we recoat new powder over, and then we build the next layer. The way this was designed, no assembly, I can now functionally use this part.
Previously, a fuel nozzle would be made of 25 or 30 very small pieces of metal, and now we can print that entire assembly just in one shot.
I wish I could show you the inside of this, because what you would see are just an amazing number of passages that snake around in this component. We find the technology incredibly enabling, being able to grow things you can't make any other way. You can't cast them, you can't fabricate them, you can't machine them.
People's Test Operations is here to test and build jet engines. We'll do anything that you might see in flight, we'll test them here. For example, if you're flying through a hailstorm, we actually throw hail through the engine. We test them in conditions that far exceed what they're going to see in real life. If you encounter a flock of birds, we actually do a bird ingestion test to make sure our engine will perform properly. We check things like fuel burn and performance of thrust and noise. Then we'll send that engine to Victorville. They'll put it on the 747 and actually go fly it. They do the same measurements that we do. So once that engine's back from flight, we'll do our post runs here. They usually head back to development assembly. They'll actually tear it down and do an inspection of every piece part. And that's how we validate that the design's ready.
So far, we've sold 8,000 LEAP engines before the first engine has even been put into production. This type of engine will power the kind of aircraft that really most everybody flies most of the time. 70% of the aircraft that are in operation are narrow bodies of this type. And so really this engine is going to become a cornerstone for everybody's everyday flying. This is a golden moment in aviation history.